Let us start fourth unit. In this, we'll be studying about multi-threading and another built-in package java.util, which is called as the collections framework. So here we have two parts. The first part is multi-threading, studying about multi-threading, and the second part is studying about the java.util package, built-in package. Now let us discuss multi-threading. So here let us see the differences between multi-processing and multi-threading. There are two distinct types of multitasking: process based and thread based. It is important to understand the difference between two. The program in execution is defined as process. Thus, the process based multitasking is the feature that allows your computer to run two or more programs concurrently. For example, we are able to use the Java compiler and text editor at the same time. Another example is we are able to hear the music and also able to get the printouts from the printer. In the thread-based multitasking environment, the thread is the smallest unit of dispatchable code. This means that the single program can contain two or more parts. Each part of the program is called a thread. For example, the text editor can be formatting the text and also printing the text. So, although the Java programs make use of the process based multitasking environments, but the process based multitasking is not under the control of Java, whereas the thread based multitasking is under the control of Java. So the differences between process-based multitasking and thread-based multitasking. Under process-based multitasking, it deals with big picture. It deals with details. The thread-based multitasking deals with thread details, with details. Under process-based multitasking, these are heavyweight tasks, whereas thread-based multitasking are lightweight tasks. Process-based multitasking, inter-process communication is expensive and limited, whereas thread-based multitasking, inter-thread communication is inexpensive. Process-based multitasking, context switching from one process to another is only in terms of memory, whereas in thread-based multitasking, context switching is low cost in terms of memory because they run on the same address space. Under process-based multitasking, this is not under the control of Java, whereas thread-based multitasking is under the control of Java. Advantages of multi-threading: it enables you to write very efficient programs that maximizes the CPU utilization and reduces the idle time. Most IO devices such as network ports, disk drivers, or the keyboard are much slower than CPU. A program will spend much of its time just send and receive the information to or from uh, the devices, which in turn wastes the CPU valuable time. So, by using the multi-threading, your program can perform another task during this ideal time. For example, while one part of the program is sending a file over the internet, another part can read the input from the keyboard, while other part can buffer the next block to send. So it is possible to run two or more threads in multi-processor or multi-core systems simultaneously. The states of the thread. A thread can be in one of the several states. In general terms, a thread can running. It can be ready to run as soon as it gets the CPU time. A running thread can be suspended, which is a temporary halt to its execution. It can later be reassumed. It can later be resumed. A thread can be blocked when waiting for the resource. A thread can be terminated. Single thread program. Let us consider a program which contains a single thread. So a thread is similar to simple program that contains single flow of control. It has beginning, body and ending. The statements in the body are executed in sequence. For example, class ABC beginning and body and ending. So multi-threaded program, a unique property of the Java is that it supports the multi-threading. Java enables us the multiple flows of control in developing the program. Each separate flow of control is thought as tiny program known as thread that runs in parallel with other threads. In the following example, when the main thread is executing, it may call thread A. As thread A is in execution, again a call is made for thread B. Now the processor is switched from thread A to thread B. After the task is finished, the flow of control comes back to the thread A. So the ability of the language that supports multiple threads is called concurrency. Since threads in the Java are small subprograms of the main program and share the same address space, they are called lightweight processes. So here the diagram shows main thread starts thread A, starts thread B, starts thread C, thread A to thread B it can switch, thread B to thread C it can switch, or thread C to thread B it can switch, or thread B to thread A it can switch. So the main thread, when a Java program starts up, one thread begins running immediately. That is usually called the main thread of your program because it is the one that is executed when your program begins. The main thread is important for two reasons. It is the thread from which other child threads will be uh, started. Often it must be the last thread to finish execution because it performs various shutdown actions. Although the main thread is created automatically when your program is started, it can be controlled through a thread object. To do so, you must obtain a reference to it by calling the method current thread, which is a public static member of thread. Its general form is shown here. Static thread dot current thread. This method returns a reference to the thread in which it is called. Once you have a reference to the main thread, you can control it just like any other thread. Let's begin by reviewing the following example. Consider the example current thread demo, public static void main. So here the class current thread demo, public static void main, string arguments, thread t equal to thread dot current thread system.out.println current thread plus t. Change the name of the thread. T dot set name my thread system.out.println after name change plus t. Try for integer n equal to 5 colon n greater than 0 n minus minus. So system.out.println thread dot sleep 1000. So the after try block, the catch interrupted exception e system.out.println main thread interrupted. So when the above program is executed, the output will be current thread main. So after name change, thread my thread 5 main, and you will get 5 4 3 2 1. So that is the output you get when the above program is executed. Creation of thread. Let us see how a thread can be created. Creating the threads in the Java is simple. The threads can be implemented in the form of object that contains a method run. The run method is the heart and soul of any thread. It makes up the entire body of the thread and is the only method in which the thread behavior can be implemented. There are two ways to create thread. Declare a class that implements the runnable interface which contains the run method, or declare a class that extends the thread class and override the run method. So implementing the runnable interface. The runnable interface contains the run method that is required for implementing the uh, threads threads in our program. To do this, we must perform the following steps. Declare a class as implementing the runnable interface. Implement the run method. Create a thread by defining an object that is instantiated from this runnable class at the target of the thread. Call the thread start method to run the thread. Let us consider the following example. Class X implements runnable public void run for integer I equal to 0, I less than or equal to 5, I plus plus system.out.println. The thread X is plus I. System.out.println end of the thread. A class runnable test public static void main string arguments X r equal to new X thread threads thread X equal to new thread r threadx dot start system dot out dot println the end of the main thread. So when the above program is executed, you will get the end of the main thread. The thread x is 0, the thread x is 1. So initially this will be printed, and then um, the thread x is 0, the thread x is 1. So up to 5 it will be printed, then the end of the thread x will be printed. Extending the thread class, we can make our thread by extending the thread class of java.lang thread class. This gives this gives us access to all the methods of the thread. It includes the following steps. Declare the class as extending the thread class. Override the run method that is responsible for running the thread. Create a thread and call the start method to instantiate the thread execution. Declaring the class. The thread class can be declared as follows: class myThread extends thread, and of course its body. Overriding the method run. The run is the method of the thread. We can override this as follows: public void run and its body. Starting the new thread. To actually to create and run an instance of the thread class, we must write the following: mythread a equal to new mythread. The thread a dot starting the thread. Let us consider an example. Import java.io.star, import java.lang.star, class A extends thread, public void run for integer I equal to 1, I less than or equal to 5, I plus plus, system.out.println from thread A I equal to plus I, system.out.println exit from thread A, class B extends thread, public void run for integer j equal to 1 to 1, j less than or equal to 5, j plus plus, system dot out dot println from thread B j equal to plus j system dot out dot println exit from thread B. Class C extends thread public void main public void run for integer k equal to 1, k less than or equal to 5, k plus plus system dot out dot println from thread C k equal to plus k system dot out dot println exit from thread C. So class thread test public static void main string arguments system dot out dot println main thread started a small a equal to new a dot start b small b equal to new b small b start capital C small c equal to new capital C small c dot start system dot out dot println main thread ended. So when the above program is executed, you will get main thread started, thread A I equal to 1, 2, 3, 4, 5, exit from thread A, main thread ended, thread C k equal to 1, k equal to 5, then exit from thread C, then thread B j equal to 1 and so on, exit from thread B. So that is the output we get when the above program is executed. Produces different output in the second run because of the processor switching from one thread to the other. So same the program if we run second time, you will get the different output. Main thread started, thread A equal to 1 to 5, exit from thread A, from thread B j equal to 1 to 5, exit from thread B, main thread ended, thread C k equal to 1 to 5, exit from thread C. So creating multiple threads. So far you have been using only two threads, the main thread and one child thread. However, your program can run as many threads as it needs. For example, the following program creates three child threads. Class new thread implements runnable string name, name of the thread, thread T, new thread, string thread name equal to thread name, T equal to new thread this comma name system dot out dot println new thread plus t dot start. So this is the entry point for the thread public void run try for integer I equal to 5 I greater than 0 I minus minus system dot out dot println name plus colon underscores plus I thread dot sleep 1000 catch interrupted exception e system dot out dot println name plus interrupted system dot out dot println name plus exiting end of the run method. So end of the new thread class multi-thread demo public static void main string arguments new thread 1 start threads new thread 2 new thread 3 try wait for other threads to end thread dot sleep 10,000 catch interrupted exception e system dot out dot println main thread interrupted system dot out dot println main thread exiting. So when a thread is ended, it is often very important to know which thread is ended. This helps to prevent the main from terminating before the child thread is terminating. So to address this problem, thread class provides two methods. Thread dot is alive and second one is thread dot join. So the general form of is alive method is as follows. final boolean is alive. This method returns either true or false. It returns true if the thread is alive, returns false otherwise. While is alive is occasionally useful, the method that you will more commonly use to wait for a thread to finish is called join. So it is shown here. Final void join throws interrupted exception. This method waits until the thread on which it is called terminates. Its name comes from the concept of the calling thread waiting until the specified thread joins it. Additional forms of join allow you to specify a maximum amount of time that you want to wait for the specified thread to terminate. So example program, mm, how the join method can be used. Let us see. New thread implements runnable string name, name of the thread, thread t, new thread, string thread name, name equal to thread name, t equal to new thread name, system dot out dot println, new thread plus t dot get name, t dot start the thread. This is the entry point for the thread. Public void run try for integer I equal to 5, I greater than 0, I minus minus. System dot out dot println name plus undercodes colon plus I. Thread dot sleep 1000. Catch interrupted exception. System dot out dot println name plus interrupted. System dot out dot println name plus exiting. So class demo join public static void main string arguments new thread ob1 equal to new new thread 1 new thread object 2 equal to new thread 2 new thread ob3 equal to new thread 3 system dot out dot println thread 1 is alive ob1 dot t dot is alive system dot out dot println thread 2 is alive ob2 dot t dot is alive system dot out dot println thread 3 is alive plus ob3 dot t dot is alive. Wait for threads to finish. Try system dot out dot println waiting for threads to finish. So ob1 dot t dot join, ob2 dot t dot join, ob3 dot t dot join. Catch interrupted exception. System dot out dot println main thread interrupted. System dot out dot println thread 1 is alive plus ob1 dot t dot is alive. Likewise, all the three threads, whether they are alive or not, will be checked. At the end, system dot out dot println main thread exiting. So the thread priorities are used by the thread schedule to decide when and which thread should be allowed to run. In theory, high priority threads get more CPU time than low priority threads. In practice, the amount of CPU time that a thread gets often depends on several factors besides its priority. For example, how an operating system implements multitasking can affect the relative availability of CPU time. A higher priority thread can also preempt a lower priority one. For instance, when a lower priority thread is running and a higher priority thread uh, resumes, it will preempt the lower priority thread. To get a thread's priority, use the set priority method, which is a member of thread. This is its general form. Final void set priority integer level. Here level specifies the new priority setting for the calling thread. The value of level must be within the range minimum priority and maximum priority. Currently, these values are 1 and 10 respectively. To return a thread to default priority, specify normal priority, which is currently 5. So these priorities are defined as static final variables within the thread. So you can obtain the current priority setting by calling the get priority method of thread, which is shown here. Final integer get priority. Let us see this example. Setting the priorities for the threads. Class P thread 1 extends thread public void run system.out.println child 1 is started. Class P thread 2 extends thread public void run system.out.println child 2 is started. Class P thread 3 extends thread public void run system.out.println child 3 is started. Class P test public static void main string arguments p thread 1 pt1 equal to new p thread 1 pt1 dot set priority 1. Likewise you can set priorities pt1 dot start, pt2 dot start, pt3 dot start, getting the priority system dot out dot println. The pt1 thread priority is pt1 dot get priority.